All right, so remember projection is u dot v, and the dot product is the sum of the product. So 3 times 6 plus -5 times 2, that would be the dot product, right? You take the dot product is u1 times v1 plus u2 times v2. That's a dot product of the vector u and v. Okay, so when I want to find the projection of a vector onto another vector, I do the dot product of the two vectors over the square of the magnitude of the vector here, v, times the vector v, right? So, and actually this is called projection of u onto v, and that's why v is over here. I'm projecting one vector onto another. I'm projecting vector u onto vector v. And so here, I'm projecting the force vector onto the vector v. The vector v is the ramp, right? So I'm trying to hold a 200-pound cart from moving, keep it from moving on the ramp. I need to know how much force is needed to apply. Now I know it's going to be less than 200 pounds, right? Because it would be 200 pounds to pick it up off the ramp. But the ramp is going to take some of the force into the ramp. Some of the force is going to be pulled down the ramp, right? It's a 30-degree ramp. So I'm going to find the projection of the force of gravity onto the vector that's represented by the ramp here, right? So that would be F dot V. F is 0, -200, right? That's the vector there. This one is cosine 30, sine 30, which is what? So V F is 0, -200, and V is going to be, what's the cosine of 30? Radical 3 over 2, 1 over 2, right? So what's F dot V? That's going to be 0 plus -100. And that's going to be divided by V, which is, what's the square root of the square? Should be 1, right? Because sine plus cosine is 1 of anything. So that's 3 over 4 plus 1 over 4, just 1, right? Squared. Okay? So the projection of F onto V is going to be that times V, or times F. Right? And
what is this concept for?
what?
What is this concept like for?
So this is like physics, the amount of force applied onto a vector.
Oh, okay.
Whoops. Yeah, and so that's going to be on V. So that's going to be this, -100 times 1. So times the vector, radical 3 over 2, 1 over 2. Okay? Okay. So here I've got the sine. So this is what I'm more concerned with, the amount to pull up the ramp. And that's going to be negative. -100 times 1/2. And so that's going to be my answer. It's going to be 50 pounds of force to keep it from coming down the ramp, right? So the quicker way to do that would be what we were doing before, which is just taking the sine and cosine, right? So what we did with the last one is we look at the ramp here, and we've got the two triangles like that, so that's a right angle. That's going to be 30-degree ramp. I know this is G, and that's gonna be a 200-pound thing. So looking at this, I could redraw that triangle. 30, 200, and, oh no, sorry, this is 200. So I'd say the sine of 30, and I'm looking at this one. I'm trying to find what's the force applied up the ramp. So the sine of 30 is going to be x over 200. This is 1/2. All right, so that's the way we did it in the last section. It was just kind of a much simpler way, right? But still the same basic idea. Yeah?
For this test, our final next week, is it all of the chapters? I forgot, or is it just
Just
one?
6. Just 6. Yeah.
Can you post a study guide or like topics that we cover?
Yeah, I'll do something like that.
Okay, thank
Okay.
you.
So let me do a really quick work problem here. Okay. So work is force times distance, right? So let's say, what's the work done by lifting 25 kilograms of sugar, kilopounds, up 3 meters? 735 Newton meters. Well, that one, I'm not going to do that one. Number 71. Number 71 in the book. All right, so I've got work. A force of 45 pounds exerted at an angle of 30 degrees above the horizontal is required to slide a table across the floor, 20 feet, right? So I think this is the problem, the extra credit problem, right? Or let's do 73. So it's 100 feet. Okay, so I'm going to exert a force of 250 pounds, at an angle of 30 degrees. It's a strongman competition. Okay, and you got to drag this across the floor in the least amount of time, right?
I don't think I did.
So how much work is done in this given period of time? How much work is done by dragging a 100-pound well, what do you say? 73?
What does it mean by how much work is done? Like what?
It's
What kind of
work
measurement
equals
is that?
force times distance.
Yeah, so work is like actual work. So I could apply a whole lot of force, but if I do it at the wrong angle, I'm not doing very much work, right? So work is actual stuff done. So how much, so I'm applying 250 pounds of force, but I'm applying it at an angle, right? And so work is in the cosine. So that's the cosine direction, right? So the work would be the 250 pounds of force times the cosine of that 30 degrees times the distance traveled, right? And what is that? 30 degrees. Okay. Right, so I think we go Newtons. You guys know Newton?
Newton's law of gravity. Is that wrong?
Yeah, Newton sort of, he discovered gravity, right? Before Newton was around, people just floated or what?
It's not really in newtons unless you have to multiply it by like 9.8 meters per second.
It's Newton, yeah, so I think it's Newton meters.
Yeah.
Wait, did Newton not discover?
But they're not in meters, so they'd have to divide it by the amount of meters, but.
Figured out, but it it was always there, so he didn't discover it.
Right, so basically what he did is he discovered laws of gravity.
Yeah.
Allegedly by the apple falling on his head, right?
I think